All right, so like I said, this is 9.4 logarithmic functions. All right, so the thing you got to understand about logarithms is a logarithm finds exponents. So I'm going to show you the notation. Log A of B. This little subscript A, that'll be a number that tells us what the base is. The B is the result. So what this notation does, when I take the log and I tell it what base and the result, it will find me the exponent that you raise A to get that result of a B. Okay, so it finds the exponent that the base is raised to get the result. So y'all, these are going to undo exponential functions, okay? So I'm just going to play with a few logarithms with you to get you used to what they are. So on these, we will find the logarithm. And our calculators will do these pretty quick, and I'll show you how to do these on that, okay? So I'm going to start with log base 5 of 125. So what this is asking me to do, you got the base is 5. So we're looking for this exponent that we would raise the 5 to, so that that would equal that result of a 125. So basically, we got to figure out how many times are we going to multiply that 5 times itself so that it equals 125. So any guesses on y'all? Oh, so you're a little high on that. So let me show you what we got. So we got our base 5 sitting here. We'll just multiply that 5 times itself until we get 125. So if I do 5 times 5, 5 times 5 equals 25. 25 times 5 gives me 125. So notice, I did that 3 times. So the exponent that you would raise 5 to get 125 would be a 3. So y'all just answer the log base 5 of 125 equals that exponent of a 3. So remember, all I'm looking for is the exponent that you would multiply or tell you how many times you're multiplying this base to equal that result. All right, try this one. Log base 2 of a 16. So what exponent would I raise 2 to equal 16? So basically, how many times you multiplying 2 times itself?
2 to the 4th.
So that would be the 4th. So this would be exponent of 4. And if you want to check these, you can sort of do what I did up here. Take your 2, raise it to that exponent, and that's got to equal 16. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So these starting to make a little sense, y'all?
Yes.
All right, so I'm gonna throw a curveball at y'all. Log base 5 of a 1. What exponent would I raise that 5 to get me a result of a 1? Oh, I got y'all on that. Oh, I got 2 of y'all. So y'all watch this. So I got a 1 on there. Well, 5 to the first would equal 5, right? But I'm looking for what exponent I can raise the 5 to turn that 5 into a 1. Oh, someone said not possible. Oh, it is possible. Watch this. Y'all ready? That exponent would be the number 0. And y'all punch this on your calculator. 5 to the 0 is going to equal 1. So when that results a 1, that exponent will always be a 0. So I'm about to go prove that to y'all. Let me go pull my calculator up. All right, so here's my calculator. So let me punch that in. 5. I'm going to use my caret for my exponent, and I'm going to put in a 0. Look what this is going to give me. Positive 1. How about 9 exponent 0? That's going to give you 1. Any number, how about this? 121 to the 0 power, guess what? That's going to give us a 1. So if that result is a 1, so let me go back to my camera. If this result right here is a 1, then that exponent has to be a 0. Okay. All right, let me let one in real quick. Log base 7 of a 7. What exponent would I raise 7 to give me a result of a 7? And now that is definitely a 1. So y'all watch this. I'm going to show you how to do these on your calculator. So we should all have a TI-84 here. Yeah, so any number raised to the 0 does give me a 1 as a result. All righty, so on the calculator to do these logs right here, when you got a base 7, I hit this math button. And when I hit the math button, I'm going to arrow all the way down. Whoops, I went too far. Until you got log base. So it's A on mine. So when you highlight the log base, you hit enter. And then look, you put in your base, which was 7 on that one. Then I'm going to arrow right. And I had a result of 7 on that one. So now the calculator is going to tell me that the log base 7 of a 7 we said was, let me hit enter, was a 1. Okay. So that calculator is pretty nice. It'll do all these for you. All right, so I'm going to turn over. All right, y'all, so try this one. Log base 10 of a 10. So that is definitely 1 again. So if that base matches that result, every time it's going to equal 1. Y'all, that could be smiley faces. The log base smiley face of a result of a smiley face is still going to equal 1 on those, okay? Log base 3 of a 1 over 81. I will say this, when your result is a fraction, your exponent will be negative. Okay, negative exponents is how we get our fractions. Oh, look at that, that's perfect. -4. Good job. Okay, so remember, fractions will give us negative exponents. And then it's still 3 to the 4th power is 81, but since it's on the bottom, we make it negative. So good job. All right, so let me explain to y'all. On the very front of your calculator, you'll see a log button, and under that, a LN button. So the one on the calculator, the LOG, we call that the common log. And it's equal to a log base 10. So anytime I got a base 10 log, I can use the log button on the very front of my calculator on the left side. There's also another button there that is a LN. So that's LN. It's called the natural log. And y'all, it is equal to what we call the log base E. So that little e we learned about last week, that's the base of the natural logs, okay? All right, so those are the quick buttons on the very front. Any other base, like a 3, 4, 5, 7, or anything else, you got to use that log base that I showed y'all in the math feature, okay? All right, so try this. LN of 1. So what is the LN of 1 equal?
I got 0.
Oh, that's what I think too. So even e to the 0 equals 1, okay? Because remember, LN of 1, it's like this. It's a log base e of a 1. And we told y'all a while ago that anything to the 0 power equals 1. Log of 1 over 10. So see, that log don't have a base, so you can use the one on the very front of the calculator. Now remember, that's a fraction, so y'all should get a negative exponent on this one. And I see a -1 up there, perfect. Okay, so 10 to the 1st power will give you the 10, but since it's on the bottom of that 1, it's got to be negative. So good job. Log base 3 of 3 to the 4th power. So that one, since you don't have a base 10 here, you got to use the log base. So go to your math and then arrow down until you get the log base. So y'all, what are y'all getting on that one? Oh, I got y'all on that. And so let's see. So let me show you how I would put that one in. So I'm going to zoom to my calculator real quick. I just want to clear that off. Are y'all ready? So I did log base. So I'm going to hit math, and oh, y'all got the answer up there now. I'm starting to see it now. So good job. So hit enter, put your base of 3 in, and then arrow right, and you had 3 exponent 4. So y'all, when you do that, you should definitely get a 4. So check this out. Anytime the base matches the result raised to an exponent, the answer will always equal that exponent. And that makes sense. What exponent would I raise the 3 to the base to turn it into a 3 to the 4th? And that would be that exponent of a 4, okay? Oh, I see what you did. Yeah, I was wondering how you got that funny decimal on that. So yeah, you said you divided it, okay. Log base 5 of the cube root of a 5. So y'all, I will show you 2 ways to do this. The first way, the calculator does have a cube root button down in the math feature. So for that one, I would punch in my log. So let me show you. For that one, I would go to my log base. So hit math and arrow down to your log base. Put that on the screen. So my base was a 5. Oh yeah. So Joseph, what you want to do when you get that kind of 0.3 repeating, hit the math button and hit enter twice and turn that into a fraction. All right, so that's a cube root. So I would hit math. Number 4 on mine is a cube root. So I'm going to hit enter and then put in my 5. So Joseph, you got the right answer. So let me show you what I'm talking about. So if you punch that in, you're going to get 0.3333 repeating. So y'all, MathLab wants that to be a fraction. So you're going to hit math and enter twice to turn that decimal into a 1/3. Okay. You just gotta watch out for MathLab. It's a little picky on those.
Can you go back to the calculator and do that again so I can see exactly how you did it because I missed it. Like
Okay,
what you went to get it.
Okay, so Joseph, yours probably ain't showing enough 3s on it to turn it into the fraction. So I usually turn it straight in after I punch it in. So let me pull this up. All right, so the one I just did, I went to my math to get the log first. I'm gonna arrow down until I get the log base. Oh, I've been going too far every time. I'm having to use my keyboard to punch mine around. All right, so I got my log base up there. My base was the 5. Then I arrowed right. So now remember it had a cube root. So I'm going to hit math. That's where you find the little roots at. So hit math, and the 4th one down is the cube root. So I hit enter on that. And then underneath, I'm going to put my 5.
Thank you.
You can log out if you want to, but now you're going to hit enter. So this is the part you was asking about. So I'm just going to instantly turn this 0.333 into a fraction by hitting math and then enter twice. So that number 1, that's what that arrow fraction means. It's going to turn it right into a 1/3. So the calculator's got so many hidden features on it. All right, y'all, how about this one? See what y'all get here. Log of 10 to the -4. So this one don't have a base. So remember, it really is a base 10 like we said up here. So since that's a common log, y'all can actually use the log on the very front of that calculator. So hit your log button, then punch in me a 10 and the exponent of a -4. So what are we getting? There we go. Bam, bam, you are quick. So that is definitely a -4. Now, if I got room for one more here, log base 8 of a 2. When your base is bigger than your result, you should get a fractional exponent. So you might have to turn the decimal into a fraction, but you should definitely get a fraction type answer. So on that one, I would use the log base. I would hit my math, go down to log base, pull that up, punch in your base 8, result 2. What are we getting? Okay, so yours not turning my decimal into a fraction. So let's go to my screen here. So I'm going to hit math, go down to log base. All right, so that was a base 8, arrow right, and I had what, a 2. So mine now, when I hit enter, it's giving me the 0.33, and all I got to do now is hit my math, because it's going to turn the immediate answer into the fraction, and I get a 1/3. So, okay, so I see what y'all did. So you pressed a different one, okay. All righty, so logarithms aren't too bad once you understand you're finding the exponents, okay? All right, so same thing.
So the one that we did, the log 10 with -4, my calculator keeps saying error, non-real answers.
Okay, so let's go back to that and punch that thing in.
I did it with the log button and went to the other one.
So follow me. Let's punch this in. I'm going to go log, and then I had my 10, and then that 10 had an exponent of a -4, and then I want to arrow down. Now,
okay.
yeah, don't put the 10 in like it's a base, okay? You want to put it in up there like it's a result on it. So now that I've got it all trapped in the parentheses, when I hit my enter, I should get my -4.
Yeah, got it. Thank you.
It's just picky on how we're writing them in, but once y'all get used to that, you'll love it. All right, so y'all do this log base 23, or how about log base 22 of 1. Oh, I figured y'all get that quick. There you go, 0. Good job. Remember, any base, we don't care what it is. If your result is a 1, that exponent has to be that 0. ln of e to the -5th. Now, y'all, listen here. When you put your answers in MATLAB, that is a small L and an N. When you punch that in MATLAB, you got to use the keyboard to push your L in. It'll make it bold and highlight it for you, okay? If you put capital I in, it will mark those wrong. It's got to be the little L. Oh, y'all are quick on that. So that's -5. You're good. So I'd have punched that in on the calculator using the, let me share that one. So that was a LN. So I would hit my LN button. E to the -5th, I would use this one, second LN. And that'll let you put in the exponent for it. So hit -5 and then hit enter, and you get that -5. All right, so let me show you one with a root greater than a third so that you can see how to do, say, fourth roots and fifth roots and so on. So for this one, we're going to do the ln of the fifth root of an e. So to push this one in, y'all watch what I'm going to do on the calculator. I'm going to hit the ln. Now, any other root than a third, you got to tell the calculator what root you're doing first. So you push the ln and then do a 5. And then in the math menu, pick the one that looks like it's got an X in front of the radical. And then we put in our E. So let me show you that on the calculator so you see what I'm talking about. So I'm gonna clear the screen. Oh man, y'all got that. It is definitely a 1/5. So here's my ln. Remember, I'm going to tell it I got to hit the 5 first. But watch this when I go to the math and I grab option number 5 on here. The one with the X. Watch this when I hit enter. It's going to turn that into a fifth root. And then since I just got the E by itself, I'm going to hit the second division to get that E and hit enter. So good job. You got a 0.2 and apparently you turned that into a 1/5. So good job. So you're getting good on the calculator for sure. All right, so that gave us a 1/5. So now I'm going to show you another thing that we do. We're going to switch these from logarithmic into exponential, and then we'll go from exponential into logarithmic. So y'all, let me find my conversion. So a little property here. Log base x of y equals b. Then I'm going to draw a double-sided arrow. This means if and only if x to the b equals y. So the base of the logarithm raised to this exponent equals the result of a y. This is logarithmic form. And this is exponential. So we got to be able to do this because when we hit section 9.6, we're going to be solving equations. And this is one of the important things on solving equations is being able to switch back and forth. So remember, the base of the logarithm becomes the base of the exponential. The exponent you found from the log equals the exponent of the exponential, and then the result equals the result of the exponential. So these examples are going to say convert to logarithmic first. Okay, so I'm going to start out with this one. 10 to the 4th equals 10,000. So we're just going to convert it to logarithmic, which means we need our log. So first question, what's the base of this log going to be? So there we go. It is definitely a little 10, which means when I put this in MATLAB, I can just punch the log. I don't even need that 10 because remember, the common log on the calculator means a log base 10. All right, the result is the 10,000. And that's going to equal my exponent of a 4. So this whole thing is what Math Lab's going to want on that one, okay? So I'll let y'all try this one. All right, so this one's on y'all. 243 to the 1/5 equals 3. All right, so we're going to start with log. What's the base of this log? So definitely 243. What's going to go next for my result?
3.
So does that look right?
3 is the result.
So it's going to be 3. There you go. So you got to bring down that 243. The result is the 3, and then that's going to equal the 1/5. Okay.
I'm lost. It's somebody ain't catching it, but I don't know what I'm not catching right now. I'm lost.
So you just got it mixed up on the little exponent. So remember, follow this pattern up here. The log, the little subscript number is your base. So that's going to be the base. The log finds the exponent. So that's going to be the exponent number. And then y is the result that we got from raising this base to that exponent. So when we rewrite it as exponential, you got to bring your base over first, which is the subscript on the log. The exponent for exponential is this exponent we found doing the log. And then the result of the exponential is the same as the result that we said was on our logs. Okay. So I just, although 243 looks bigger, it is still the base. So, and then you can check these out on those calculators, okay? Punch in 243 to the 1/5 power. That will give you that 3. All right, y'all. E to the 5th equals R. Yeah, that's all I'm doing. It's just plugging them right into your formula, okay? So good job on that. All right, so try this one. Log. What is my base? So my base is the E. So remember, that's what we said here. Follow your formula over here. The base becomes the base of the exponential. Now, the result is the R, right? So the R would go here. And the exponent is the 5. There you go. Okay. So E to the 5th equals R is basically what we're, so remember the log is finding the exponents. The exponential is finding the result. Well, it's hard to explain these things, but I'm going to try to keep going with y'all. All right, y'all try this one.
Can you show me how to put that last one in the calculator?
What now?
Can you show me how to put the last one in the calculator?
This one?
The ER, yeah.
Well, we can punch E to the 5th in the calculator, but it'll probably give you just a number.
Okay.
They just got that R there to try to make y'all see that y'all got the pattern down.
Gotcha. Okay.
Okay. Now, if they give me like 3 numbers for everything, then you can probably find that one. See, like this one, they're giving us what? P to the K equals 81. So we're not able to do variables on a calculator. So I'm going to test y'all out. Here's my log. What's the base of that logarithm? So it is the P. The result here is the 81. And that's going to equal my exponent of A. I know what you meant there. And then that equals the K. And that's all we're doing, is converting that little 2-way arrow I gave y'all. So that's going from exponential to logarithmic. Now we're going to go into logarithmic into exponential. So we're going to convert to exponential. All right, so they're giving me log base 5 of 125 equals 3. So we're going the other way now. So first thing I need would be the base for my exponential expression. I'm gonna guide y'all on this one. The base, remember, is the same as the base on the log. So it's going to be the 5. What's my exponent on that 5 going to be? 3. Good job. And 5 to the 3rd is going to equal 125. Okay, so remember, base, exponent, result. So if you notice today is, other than doing these conversions, today everything is able to be done on that calculator. We just can't do all the conversions on it because of the variables. Right, y'all, log of 0.1 equals -1. So I didn't give you a base this time. So what base is on this common log?
10.
So that is definitely a 10. All right, so what's my exponent?
1/10 or -1.
So -1, and then that's going to equal the
1/10.
0.1. There you go. So Zach, here's the thing. When there's not a number down here on the log, that is automatically a 10 sitting down there, okay? And that's the one you can do at the front of that calculator. But remember, you can punch in the log of 0.1 and it'll give you the -1 as the answer. Okay, I see you missed the 1. Okay, good job.
Okay, so I have a question. I'm a little slow today.
Yeah, I'm hearing you.
Okay, can you put that in the calculator for me? Is it possible?
Yeah, but it won't convert it. It'll just give me that answer.
Okay, so I missed it. I didn't see the 10 down there. It was a little small.
Yeah, that 10.
Okay, I didn't see it.
Yeah, if there's not a number here, we automatically assume it's that 10, okay?
Okay.
Right, y'all, ln of 52 is going to equal 3.9512. So that's the ln. So what is its base?
E.
E. So there you go. E. My exponent?
3.9512.
Good job. And then that's going to equal my result of?
2.
Good job. Okay, so log by itself is a log base 10. ln is a log base E. So good job, y'all. All right, one more of these. We're going to do log m to the capital T equals -y. Now be careful. Small letters, you got to keep small in MathLab, and capital letters, you got to keep capital, okay? So the first question, what's my base?
M.
Exponent.
-y.
And there you go. M to the -y will equal that capital T. Good job, y'all. So next few sections just want us to use the calculator to estimate common logs and natural logs. So we'll just be punching the very front buttons on these calculators, okay? Now the thing they want us to do, estimate these to 4 decimal places. So use a calculator to find the common logs and the natural logs. All right, now remember this. I'm estimating 4 decimal places. So my 4th decimal place will depend on my 5th decimal place. If my 5th decimal place is 0 through 4, I'm gonna keep it the same on the 4th number. If my 5th decimal place is 5, 6, 7, 8, or 9, I'm gonna round that 4th place up. All right, y'all, so log 64. Now I'm using these little squiggly equals because those mean we're approximating and rounding this off, okay? So y'all, you'll see that on the very front of your calculator. So I'm gonna go to my calculator. So on the calculator, let me clear that. On the calculator, the log button's on the very front. So hit log and then punch in your 64. So now when I do log of 64, I get 1 point. Well, I'm going to do the 806. So my 4th decimal place is a 1. But behind the 1 is a 7. So since the 7 is 5 or greater, I'm going to round that 1 up to a 2 so that this gives me a 1.8062. Now, if you're weak at rounding stuff, watch what I can do. So this is to help you round for 4 decimal places. Hit that mode button. When I hit the mode button, I'm going to arrow down to where the float is highlighted. This does your decimals. So if I want to round this to 4 decimal places, I'm going to go right and highlight 4. So highlight the 4 and hit enter. So it puts the box on 4 now. So that means we will now round our calculators to 4 decimal places. So when I quit that, now watch when I hit enter, it's going to take that answer and round me 4 decimal places. So you don't have to switch that. So I would do that on this whole assignment. And after the assignment, put it back on float so that it don't mess up other stuff. Okay, but for this assignment, you can keep that on a 4 and be done. All right. Don't matter. So what do we get? A 1.8062. So we're just rounding these off about 4 spots, okay? How about this? Log of 2. So y'all want to try that one? Round me 4 decimal places on log of 2. .3010, that's perfect. So y'all getting that on your calculators?
Yes.
All right. So let me turn it up a second. Not too bad though. So let me turn this. I hate it when it folds up. All right, so let me see what y'all put on this one. Log of a negative 36. Yeah, you don't have to put the 0 in front of the decimals when you're rounding it off. Zero's just, that first 0 is mainly like a placeholder. But if the 0 comes after the decimal, you want it then. Oh, y'all are so close. It is an error on that one because there's nothing I can do to a 10 with an exponent to turn that into a negative 36. So the official thing you want to put in Math Lab for this one is that it does not exist. And y'all, they'll give you a choice B when it does not exist. You just highlight B and be done with it, okay? And remember that when we do our equations, because when I do my equations later, if I get negative answers and I try to take the log of them negative answers, that's when you're going to get no solutions later on in life, okay? All right, y'all, round me off. 4 decimal places on a LN of 53. So 3.9703 looks good to me. All right, so y'all try this one. LN of 143.4. So when I got 4.9656, looks good. So Janae and Zach on a roll, so y'all try this one. LN of a negative 1.19. So not defined, which means it does not exist. So good job. Now, I don't think it'll give y'all the no solution options on those ones. Since these ain't technically equations. So remember, these ones just put does not exist, which would be y'all's choice B. All right, toward the end of the homework, it says find the log using change of base. Use the base, the log base in your calculator that I showed you in the math feature. So find the log using.
Hey, he's back. The Golden Knight from F tier to A tier. Could probably
Say that again.
I think
Someone
that was
said something. I heard something, but I didn't get the question. I couldn't hear it
I
good.
think it was an accident, Dr. Rafton.
Oh, okay, okay. All right, y'all. So watch this. Log base 6 of 18. So y'all, let me ask y'all this. Does every one of y'all's calculator have the log base on it? So let me go back and show y'all what I'm talking about. So when y'all hit math, everybody's got log base on them. So then when y'all hit enter, y'all can punch that in as what, a 6. Arrow right, put in an 18. And then hit enter. And they'll tell you in the answer blanks, they still want us to round these 4 decimal places, okay? So that'd be what, a 1.6131. But y'all, I just want to show, let me show y'all a trick. if you don't have that log base in your calculator, to find this answer, you would do the log of 18 divided by the log of the 6. It's always the log of the result divided by the log of the base. Watch what it does when I do that. So let me go back. So I can do the log of the 18, close those parentheses, divide by the log of the base, which is 6, close those parentheses. Watch this answer when I hit enter. I still get 1.6131. So before Texas Instruments upgraded the calculators, this is what they meant by change of base. The old method. But y'all, I'm not gonna lie. I'm probably just gonna hit log base on my calculator, put my 2 numbers in and be done, okay? But either way, you will get the number you need. All right, so one more of these, and then I'm gonna show you about the graphs. So y'all, what about this? Log base 3 of 70. Oh, I lied, I had 2 more. So round me out 4 decimal places, y'all. So 3.8671 looks good. Okay, so this will officially be the last one. Log base 5 of a negative 125. And what's funny, you should do this one both ways, and it's still going to give you that same. So undefined or does not exist. Good job. The reason they say does not exist instead of undefined, because remember, undefined is what you get when you're dividing the fractions by 0. And what these are, these give you what we have called imaginary type answers. So they're not real in the real world. We just say they don't exist. All right, y'all, so I'm going to show you what a logarithmic graph looks like. So what I'm going to do is I'm going to graph. So let me find that. Log base 3 of an x. Whoops, I forgot my y equals. So that's really a y equals log base 3 of x, okay? So I'm just going to make me up a table to graph this with. And sort of show y'all some properties about these. Now, y'all got calculators. You can punch these on the calculators because all MathLab does is make you pick out of 4 different pictures. You do not physically have to graph these in MathLab, okay? So I'm going to go out 5 every direction. Now, the other day, remember my exponential graphs that we did last class, exponential graphs came up, went through 0, 1, and curved up, okay? The asymptote they had was on the x-axis. So it came in, but remember it went through the point 0, 1, and then it curves up. Now we're going to do logarithmic. So I can't put a 0 there because there's nothing I can do to a number and turn it into a 0. Okay. And if you try to punch 3 with an exponent 0, a log base 3 with a result of 0, it's probably going to give you an error. So let me show you. So let me go to my log base. All right, hit enter. So if you put a 3 for that base, you cannot use a 0 for the x, because watch what it does. It tells you you got a domain error. That means it's pretty much undefined for that 0, okay? So let me go back. So I cannot use 0 as the x. I can use a 1. What exponent would I raise this 3 to make it equal a 1? So that would be a 0, definitely. So instead of these going through 0, 1, like all the exponential graphs, all your logarithmic graphs go through 1, 0. Every single one of them is going to go through that point unless you shift the graphs, okay? All right, let me think. What if I put a 3 in for my x? If I put a 3 in for x, what exponent would I raise 3 to turn it into a 3? That'd be a 1. So over here at 3, I'm at 1. All right, so I'm just trying to find numbers that I know I can get from using this 3 as my base. So the next number I'd probably put in for my x would actually be probably a 9. What exponent would you raise 3 to turn it into a 9? That'd be a 2. So way out here at 9, it's barely getting up to a 2. Now remember, it's undefined on the y-axis. Remember, we can't have answers that make this undefined. So let me do fractions. Check this out. If x was 1/3, you got log base 3 of 1/3. What will, oh, bam, you are quick. That's a -1. Good job. So over here at 1/3, you're down at -1. Try one more for me. How about if this is a 1/9? So that one would be a log base 3 of 1/9, y'all. So -2, good job. So at 1/9, which is closer, I'm at -2. So what's going to happen, the closer you get to the y-axis, these are going to come straight down. Try to get to the y-axis, but it never gets there. And then the right side's just going to try to grow over time towards infinity. So notice these, remember your exponential graphs went through 0, 1 and came up, hit that, and then they went up. So these graphs, if you notice, are inverses of each other. So I think they'll have one where you got to graph them both and fix the picture, okay? But y'all watch this. On them, I'm just going to go to my calculator. So let me hit my calculator, go to y equals. So let me clear that out. That was from the birthday party. So this was log base 3 of x. So I would hit math, get the log base down here. Hit enter. So my base was a 3, and then my result was that x. So we just want to see the graph first. So see how it's trying to get to the y-axis here, and then it curves up. And if you look at the table, second graph for the table, anything 0 or less that's negative, it's going to give me an error because those do not exist. I can't turn a base into a negative result. So any one of those where we had negative x's is definitely going to give us an error. Now, if you set your table, since I had a base 3, I did those 1/3 and 1/9. If you changed your table set, so second window, and if you do this delta table down here by 1/3, and then went to your table, it'll give us all them values where I was doing the 1/9 and 1/3. Okay, so let me go up. So that 1/3, I got -1 Walgo member. And if I made it by 1/9, I'd get that -2. If I did -1/27, I would get a -3, and so on. You know, I'm telling you the truth, I would probably just I'm gonna put that back on 1 for my graph. Oh, okay. So let me ask you this, Jordan. You're not getting the graph at all. Is it saying an error message or anything?
No, it's just blank.
All right, so
I
do
wonder
this.
if my table setup is weird.
Well, what I want you to do is this: hit the zoom button. When you hit that zoom button, go to number 6 for a standard, and let me know if
Okay.
it's graphing yet.
Yes.
Okay, so your window must have just been too big or something.
Okay.
So you're getting my graph now?
Thanks. Yep. Yep.
So
Thanks.
anytime y'all don't get your graph looking sort of like they got, just go to zoom and hit standard, and it'll bring back a 10 by 10 graph for you. All right, y'all, so that's the world of logarithms. Next class, we'll start going over properties of logarithms, and they're sort of similar to the properties of your exponents, because remember, logarithms really are exponents, right? So that's what's coming up Thursday. And y'all remember, we got this week, next week, and then we're going to start getting ready for your last test, your final, and all that. So I'm hoping to have a good week to really go over that final, because it's been a while since y'all did test 1.
How many questions is gonna be on the final?
25 multiple choice.
Okay.
So at
And when we
least,
gonna start reviewing for it? Cause it's April.
say again.
So when we gonna start reviewing for it?
Well, here's my plans. I'm gonna knock out 9-5 next class. Next week, I'm gonna do 9-6, 9-7. And then right after that, we're gonna knock out your test 4, review for my final. So final start May 4th.
Okay.
So I think that's on like a Wednesday. Okay. So we should have plenty of time to go over that final. But like I said, it's 25 multiple choice questions. So if you don't get one of them 4 answers, then you probably made a mistake. So go back and figure out that, and then try to get them answers, okay?
Okay, thank you.
So it's not hard. It's like Math Lab, y'all would have to go in and write all your answers. And if you put extra blanks or dots instead of commas, it's going to mark all that wrong. So we didn't want to go through that on the finals, okay? So we just wanted y'all to go A, B, C, D, hit enter, and be done. All right, y'all, so I'm going to shut this down. I'll send this out in a little bit. We'll come back in Thursday and knock out 9-5, I think it is. Yeah. Okay.
Okay, have a good night, y'all.
All right, y'all have fun on that calculator. I'll see y'all later.
Good night.